From yesterday, we have I have shown you a lot of use of calculators, how to use the calculators, and we find the width of the island, and we have find the highest point of the island, and then we find the distance between Victoria and that island, and we talk about the domain. If you subtract two functions, the domain will be the intersection between the two functions, and then we talk about the distance. What is the shortest distance from the balloon and the island? We sketch that graph in the graphing page, and we find the minimum point. And then we talk about the tangent equation. So at the point 1,200, they shoot missile missile from the launch site, and then trying to shoot Victoria. So the path is the tangent line for that point. And then we say they intersect at the path, like the missile and the path intersects at that place. That's where we are up to yesterday. So we have actually solved those two functions. We have solved out two values. Okay, we have solved out two values. And then we choose the value within the domain, which is this one, okay, the minus 1,000. So if you can expand that, that will become 2,000 minus 1,000 root 2. 2,000 minus 1,000 root 2, and that's 100 plus 100 root 2. So that's the coordinates. Because the question hasn't asked you to find the decimal, so we keep the answer in the exact form. So that's the intersection between that point and the path. Okay, now let's have a look for the next question. So when that crossed the path of Victoria's balloon, okay, the path of Victoria's balloon, so not necessarily Victoria's at that point. Victoria balloon is at the same height above the sea level as that missile, but at the different point on the height, on the flight of the path. Okay, so what that means, if we go back to that graph, I have, okay, that's how you shoot that and then pass that point. But that's only the path. So Victoria is actually at the same height of this point. Okay, at the same height of that point. So Victoria must be on the other side of that. Okay, so Victoria is actually here somewhere. So if you can draw a horizontal line from that red point, so Victoria is here. So Victoria is here. Okay, that's the 1,000. All right, and then let's have a look what's going on here. So at this instant, Victoria fires a missile from the balloon, which travels in a straight line to hit the launch site at the point 1,200. So Victoria trying to fight back. I can use a black color to show the path. So that will be the path. Okay, that one will be the path. So that's from the Victoria, and the blue one is the enemy. So trying to shoot that way. Okay, trying to shoot that way. Okay, so everything's clear now. And the next thing it says, let theta be the angle of Victoria's path makes the angle with the horizontal. Give theta equals to tangent inverse 1 over p, where p is a constant. Find the value of p. Okay, so when you see theta equals to tangent inverse, what do you need to think about? Like, that's related to what? Gradient. Okay, gradient. So what we can say is tangent theta equals to 1 over p, and that is the gradient. That's what we can convert to. Okay, that's related to the gradient. Tangent theta equals to 1 over p, and that is the same as the gradient. So what this question is actually asking, they ask you to find the p-value, but if you know the gradient, you will know the p-value, right? It's the inverse of the the gradient. So therefore, what is asking here is asking you to find the black line's gradient. Okay, the black line's gradient. So there will be two ways to do it. There will be two ways to do it. I will go through the complex way first. But like, okay, so for math question is always like that. If there's like two methods, one method will use like more thinking, but it will be a very easy method. You can directly write your answer out. But the other one will be go through a lot of tedious calculation, but in the end you can solve for it. It's a very easy thinking, but you need more effort to work it out. So let's go through both methods. Like you just choose your suitable way. You can't say like which one is better, which one is like worse, but it will all be the same. Just depends on what you can think about. So if we think about the very straightforward one, you have this red dot. What's the coordinates here? This dot. 1,200. That's this point here. Okay, so how you can find the coordinates of the green one? That's my question. How you can find the coordinates of the green point? Yes?
You have the coordinates of the
yeah, the red one.
And then it will have the same lava.
Okay, that's right. So we have this value. Well, I forgot there was, I think that's 2,000 minus 1,000 root 2. That's the x coordinates. And the y coordinates is 100 plus 100 root 2. So we have the same y value, okay, for this point and this point. So I can find the coordinates of that one because I know the equation. I know the Bloom's equation, okay, that's the equation. So let's do this. We can find, that's the equation. Open my calculator. Well, if we keep doing this question yesterday, we have defined function bx. We can directly make bx equals to 100 plus 100 root 2 and solve for x. We can do that way. But today I need to type the function again. So I can go menu 3.1 to solve for that. We have, that's minus minus x squared over 20,000, I think, plus x over 10. And then plus 200. That will have the same height. So there will be two values give you the same height. So we can say that's 100 plus 100 root 2. And then comma x. So for that, okay, we can see this value is the left hand side value, okay, the 2,000 minus 1,000 root 2. So the other value must be 1,000 root 2. So the other value is 1,000 root 2. So this green point got 1,000 root 2 comma 100 plus 100 root 2. So we solve that by using the calculator, same height, and solve for it. So if we write this here, we'll say one point is 1,000 root 2 comma 100 plus 100 root 2, and the other point is 1,000 comma 200. So we want to find the gradient between those two lines. So we'll use 100 plus 100 root 2 minus 200 over 1,000 root 2 minus 1,000. So that equals to 100 root 2 minus 100 and 1,000 root 2 minus 1,000. We can take 100 as common factor, that's root 2 minus 1. And I can take 1,000 as the common factor, that's the gradient. Okay, gradient between those 2 points. So that equals to root 2 minus 1. So those two can get cancelled. What we have is 1 over 10. So what we have is the gradient equals to tangent theta equals to 1 over p equals to 1 over 10. Okay, so where we have the gradient thing, we have it here. Okay, the gradient equals to tangent theta. Also, we know tangent theta equals to 1 over p. Then that's 1 over 10. Therefore, we have p equals to 10. Okay, we have p equals to 10. That's the first method. Like, that's very straightforward. That's according to what the question gives us. We just find coordinates of the intersection, find the gradient between the two lines. But the most important thing is, well, when you see, like I do this question, you say, oh, very straightforward. But it's very difficult to think from the first, like the start, like the very beginning. What is asking? Okay, you need to know what is asking. Students see this question, oh, tangent inverse, oh, p. Where I can find that p? They focus too much on the p value. But you need to know when you see theta, tangent inverse, that must relate to a linear and the angle in between the linear and the positive x-axis. Then you will think about, oh, that's asking for the gradient. If you know it's asking for the gradient, everything's easy to solve. Okay, so you need to know what is asking for one question. That's the first method. But if you can think about the second method, at the very beginning, when I start this question, I'm asking you a question. What kind of equation is Bx? What kind of equation is Bx? Like, what's the name of the equation? Hyperbola, like truncus, what's Bx? Remember that? If you go back to Bx, parabola. So, this is a parabola. And then 2 points are at the same level, which means they must symmetrical about the turning point. Okay, the line, like if you draw a vertical line about the turning point, that must be symmetrical points. So I'm thinking from another point. Think about the symmetrical point. Okay, introduce another, like I think this is another calculator use. Just introduce another thing in the calculator. I'm not sure if you know this. If you can go menu number 3 algebra and you go complete square. There's a function called complete square. Menu 3 and 5 complete square. Okay, so I want to complete square. Why I need to complete square? I want to see the turning point. So I'll copy this equation, well, just this half here. But remember, it needs to put, I think it needs to put a comma x to indicate like the variable is x. And press enter to complete the square for you. Can you see where is the turning point? Can you see it? What's the turning point for this equation? If you add the 250 to the other side, at the back, what's the turning point? Can't see it? If I can 1,000 and plus 250, so the turning point form is minus 1 over 20,000 x minus 1,000 squared plus 250. Okay, I can rearrange that. Can you see the turning point now? That's the turning point is 1,000 and 250. Okay, what's the interesting thing here? Like when you see this turning point, what you can think about? Why I want to find the turning point? Do you know why I'm thinking about this? Yeah, gradient equals to 0, that's true. But if you guys think about this red line, if you extend this red line, you can touch the turning point. Can you see that? If you extend that line, that's the middle. Can you see this red line? If I can extend that, because you have x value 1,000 here. So that line is x equals to 1,000. So actually this point is just in the middle, like, of this quadratic. Okay, so that's the turning point. If you're touching the turning point here. So why I want to say this? Can you see these two lines, the black one and this blue one? Can you see they are symmetrical lines? Can you see they are symmetrical? Because this is the middle. I'm not sure if you can think about this, but try to think this way. That's the middle of the quadratic. And then you have same height from both sides. Trying to shoot the same point in the middle. They must be symmetrical like lines. Okay, this angle equals to that angle. And if you can extend that longer, those two angles must be the same with the x-axis as well. It's isosceles triangle. Like if you can extend this longer. If you can extend longer, this black line go to touch the line here, and the blue one going to touch the line somewhere here. But this angle and this angle will be the same. Okay, this angle, like this theta and that theta, they will be the same. If you can draw a quadratic, find the same height point, shoot the middle, any point on that symmetrical line, they will make isosceles triangle for you. So do you remember what's the equation for the blue line? Do you remember that? What's the equation for the blue line? Do you know we find it before? Yeah, what's the equation for that? Negative 1 over 10x. So the blue line got y equals to negative 1 over 10x plus 300. So this black line must be y equals to 1 over 10x plus something. I don't know what's the something, but it must be 1 over 10x plus c because of the symmetrical property. Okay, that's two lines symmetrical. So this one is a positive, this one is the negative. So that's negative 110, that one must be positive 110 as well. So we can directly say the gradient is 110 by using the previous question's answer and then say p-value is 10. That's almost like no calculation. Can you see that? Like the only thing is I'm confirming that middle is 1,000. That middle is 1,000. And then because of the symmetrical property, those two lines are symmetrical lines. And then that's negative 110. The other one must be 110. And they'll directly say P is 10. But I think very few students will use this method to really do this question. So finding the coordinates and finding gradient, that would be the most straightforward way to do it. But you can see there's a lot of calculations involved. But not that hard, but still you need to calculate things. But for this method, except I put the equation in and find the turning point in the calculator, all the rest I'll by thinking and directly tell the value. Okay, so that's the different two methods. I will recommend the first one because the second one can be too hard. If the turning point I find if it's not in the middle, that's just a full stop. We can't keep going with that. Because that point is just in the middle, then we can say that's 10. Okay. How I think about this, I think when I see this question, I say, wow, that's about the middle. And also because it's a quadratic, I think there must be a reason give a quadratic and the point seems like in the middle. So I try. This is like I'm trying to see whether it's in the middle or not. I have like a curious, is it in the middle? And I see, well, it's in the middle. Therefore, this value must be 10 here. Okay, so it goes through by that. Any questions? Go back, that's the 10, that's the first method. I can't really show the second method. It's all by thinking. Any questions you want to ask for this whole question? The calculator is the very important thing. I'm not really saying this question is like, this question is good because it's very suitable for like the beginning level, but the more important thing is how we use the calculators. Okay, how we use the calculator. Okay, if you don't have any questions, just trying to complete the rest of the notes, the inverse function and the composite function question. I'll upload solution for you Monday or Saturday night.